Hello. Hello, can you hear me? Hello.
Yes, I can hear you.
Okay. Okay. So just we are waiting for 2 minutes. Then we will start our second day's online training session. Okay. Just wait for 2 minutes.
Okay.
Okay. So now we will start our today's session. Okay. They are also need all of the recorded video classes. So that's why today they are not joining this online training session. They are need only for this recorded session. So we will continue our second day's online training session and then move to forward. Okay. So I simply share my
Okay.
screen. Just
Okay.
okay. So yeah. Okay. So now can you see my screen? Yeah. Can you see my screen now?
Yes.
Okay. So first of all, I will try to discuss about our yesterday some previous part for reprojected the scale factor on Google Earth Engine for NDVI. Here you can see here we already added a NDVI map, and this is the last topic for the previous class which you completed for importing the MODIS data. Then we also calculated the NDVI between this time period. Okay, total 5 years data we will take, and then we also show the image like this. But here we can find a problem. This problem is that here you can see when I click on this inspector tab, you can see here when I click on this inspector tab, it's showing like this result. You can see when I click to here, it will be showing the result is that 5745. You can see when I click to here, you can see this result like this. But we already know about that. What is the value of the NDVI value range? You can see NDVI value range is that between this time, you can see between this +1 to -1. So NDVI values always consist this range +1 to -1. But in this time here, you can see when I click on this map for get the specific pixel value, I can get the pixel value like this 5872. But this value is not maintained this range -1 to +1. Okay, because this data set is the globally. Okay, in this time I need to use the data set for my local region. Okay, so when you want to use the local region, you also need to use here the scale, your local scale. Okay, because you can see this data set is right when you want to work with the whole world or whole earth, you want to observe the NDVI, then this value is the right. But when you want to work with for your own local region, it can be your any country or any district like this. When you want to work with the local region, then you need to use here the local scale, and where you can get the local scale value. So here you can see I simply open this data sheet in here. So this is our data set. I simply copy in the and just okay, so I simply copy this that data set snippet from here, simply copy and then paste here, and then you can see this is my data set, and this data set is the global 250 meter resolution. And here you can see they are also provide the value for the global value for NDVI. They are providing the mean NDVI, it will be start from the -2000, and max NDVI value is the +10,000. But in this time I did not work with for the whole world, I need only for my own region of Bangladesh. So that's why in this time I need to work with the local scale, and they are already provided. You can see they are already provided the scale. Here you can see this is the scale. Okay, so this is the scale value 0.0001. So this is the local scale value. So when you want to work with this local scale value, in this time I want to just use this scale value. Okay, so here you can see how much image I can get from here. You can see between this time period I get total 138 images. Okay, here I can get total 138 images, but this image is not reprojected the scale value. In this time I want to make it the reprojected scale value. Okay, so in this time just I multiply this scale value. You can see what is the scale value. This scale value 0.0001. This is the scale value 0.0001. I just simply multiply this scale value with my total 138 images, which image is consisted between this time period year of 2015 to 2020. So in this time my goal is that I simply multiply with this scale factor 0.0001 with my all of the images. And how many images I can get? I can get total 138 images. In this time I just simply multiply, okay, all of the images. In this time here I can get the total 138 images. So there are a lot of images when you want to work with this. There are a lot of images, 138 images, okay, and you need to multiply every each images with this scale factor. Okay, so in this time I will take the help of function. Okay, function can be help me for multiply all of the images together. I need to in this time when you use the function, you don't need to add the one by one and multiply. You don't need to this. Okay, you can just use the function, and this function will be help you for multiply all of the images with your scale factor 0.0001, and you can get the reprojected images. And when you use the reprojected images, you can get the value between the -1 to +1, this range. So in this time, we just multiply all of the images into our scale factor 0.0001. Okay. So okay, let's go. We will try to do this. So in this time, I simply just try to make a function. So I simply take a variable. I take a variable. Suppose this variable name is the scaled NDVI. I simply put the variable name is the scaled NDVI. Okay. In this time, I create a function, and previous class I try to discuss about the function. When you want to create the function, you need to use here the function keyword. So I simply use here the function keyword. Okay. After this, you need to add here the element. So in this time, simply you add the element. Okay. Element, in this time you can say that what is the element. Element is that all of the image. Okay, 138 all of the images. Suppose 1 image, 2 image, 3 image, 4 image, 5 image, 6 image, and up to 138. Okay, so in this time, here you can see, in this time my element is that all of the images, you can see 1, 2, 3, 4, 5, 6, and up to 138 images. All of the images is my element. Okay, in this time I want to multiply all of the image with my scale factor. So that's why I simply put here this all of the images. In this time I can take the another variable. Suppose all of the images, I considered all of the images is stored in a variable. This variable name is the image. Okay, so I simply use here the image. Okay, so just you can consider it. All of the images from 1 to 138, all of the images is stored in a variable. This variable is the image. So image is stored all of the number of variables. Okay, so you can just consider it. Or image, this element is consist of all of the images. Okay, in this time I simply use here the curly bracket, and in this time I simply use here the return function. Return, in this time I want to multiply all of the images, and you can see I already considered all of the images is the image. Okay, so I simply use here the image. Okay, then I simply use here the multiply. Okay, multiply with the scale factor 0.0001. Okay, I simply multiply with my scale factor. In this time, here you can see, in this time I add only for the one image. Suppose you can see this is the one image. Suppose you can see this image has stored only for the one image, but I need to multiplying process for all of the images, all of the total 138 images. Okay, so that's why I simply use here the copy properties. Copy properties. Okay, then what is the copy properties? I want to copy properties this image. And what is the range? I want to range all of the images between this time period, year of 2015 to 2020. So I simply use here the system time start, as well as also I use here the system time end. Okay, so it's identify the system time start and system time end is that it will be start from the year of 2015 1st January and move to the year of 2020 December 31. This is my system time start and system time end. So this system time start and system time end, all of the images multiply with this value 0.000 this value, this scale factor. Okay, so in this time you can see this is the function I created. In this time, if you have any question about this function, you can ask me. Any question or any confusion or any doubt about this function, you can ask me. Any question or any doubt about this?
No.
Okay, and when you face any confusion or any doubt, then you can ask me. So that's why you can also get the lifetime solution. So that it will be very easily, you can easily understand. So you can see in this time what I can do. In this time, this is the image. So here I already, you can see 138 images. Suppose you can see this is the first image. Okay, so this is the first image, and this first image I multiply with this value. But in this time I want to need to multiply all of the images between this time period. Between this time period I want to need all of the images. Okay, so that's why I simply use here the copy properties function, and then I simply use here the system time start and system time int. Okay, so that's why which system in including my time, you can see here of 2015, and what is the in time 2020. Between this time period I can get all of the images. It will be multiplied with my scale factor. In this time you can see you can see this is my function, and this is my filter NDVI. This filter NDVI stored total 138 images. Okay, this filter NDVI stored total 138 images. You can see this is my function, but this is my whole collection 138 images. Okay, in this time you can see there is the no connection. There is the no connection with my function. This is my function, and this is my whole collection. In this time there is the no connection. Okay, so in this time I want to connect my function which I created with my total 138 images which stored the filter NDVI. So for this I simply copy this, and I simply copy the variable name. Okay, and paste here. I simply copy, only for copy the filter NDVI, because it stored the total 138 images. I simply copy, and then I simply use here the map function. Okay, so map is a function. It's just connecting with my function which I created with my full collection. You can see this is my function I created. In this time I want to just add this function with my collection filter NDVI. This filter NDVI consists total 138 NDVI images. Okay, so that's why I simply use the filter NDVI and use the map function. So map is a connecting function. You can see I created this function. I created this function. So that's why all of the images will be multiplied with this scale factor, and I want to add this function with my all of the images. Okay, this image is stored at the filter NDVI, and in this time this is the map function. This map function is helping me for connecting with each other. In this time I want to check how many images I want to get after using the scaled value. So I simply copy the scale NDVI this, and then I simply paste here, and then I simply use here the size function. You can see size is a function. It's determine how many images is available in this variable. I simply click to the run. You can see what happened. In this time it will be showing me how many images I can get after applying the filtering scale. Here I can get the same image 138 images. Okay, so in this time I simply copy the scale NDVI. Simply copy, and then I simply copy this variable, and then I simply just use here, because in this time I want to create this map using the scale NDVI images which I can get the total 138 images. Okay, and then I simply click to the run. You can see what happened in this time. In this time I can get the value between this range -1 to +1. But in this time you can see this map is the totally showing as a white color, because you can see it will be showing the white color, because you can see in this time it will be showing the mean NDVI value from the 0 and 8000. Okay, but I reprojected it, so that's why in this time it will be -1 to +1. I simply use here the -1 to +1, and then I simply click to the run. So in this time I can get the proper visualization. You can see I can get the proper visualization, and when I click on the corner inspector tab, and then I simply click on this any portion, you can see I can get the 0.6. When I click to here, you can see I can get the -0.03. In this time I can get all of the value between my range. You can see my NDVI range is that +1 to -1, I can get the value between this range, +1 to -1. So now this value is the reprojected. Okay, I can get the reprojected scale value. Okay, I get the reprojected scale value. You can see I can get all of the reprojected scale value. In this time, if you want, you can simply export this map. You can simply export this map as a TIFF format, and you can easily work with the ArcMap software for making the map like this. Here you can see this is the map for the Colombia. So mainly in this time, I can simply download the TIFF images. I can simply download the TIFF images from the Google Earth engine. Then I can simply make the map for my research paper work. Okay, so here you can see this is the better map we can get from the Google Earth engine TIFF images. Okay, so we can get the better image. You can see this is the Colombia NDVI map. You can easily export this map, export this map, and then you can simply make the map layout and other things easily. Okay, using this map.
Yes, yes.
Okay, in
the
this time,
Google Earth.
yeah. Any question?
No. Just
okay.
We will make this in the ArcGIS.
Okay, so I also try to show you the next class how you can easily make the map layout and other things, so that you can easily understand. Then you can also create the map like this for your research paper or other things. So I also covered this part after completing our land cover classification, because land cover classification map, many person they are not to how to make the land cover classification map. They know about the make the land cover classification map in Google Earth engine platform, but they did not know how to use this TIFF image in ArcMap software for making the map. So in this time, after completing the land cover classification map, I also try to show you this part in ArcMap software for making the map layout or other things. Okay, okay. So in this time, you can see in this time you can easily export this map. So how you can easily export this map as a TIFF format? So mainly when you want to export the map, you can simply use here the export image to drive. Okay, export image to drive. In this time, I simply, you can see here you can get all of the argument. In this time, I simply make a dictionary and put all of the argument, keyword and key value. Keyword and key value. Keyword and key value. Okay, in this time I simply put out the keyword and key value. You can see first of all image. What is the image? You just remember that this key value is that which object you want to show on your map. You can just simply put this variable name. In this time I want to show the object of NDVI, and what is the variable name of this object? You can see study area. I simply copy and paste here, and description can be anything. You can just put here the description anything. I simply put the description, suppose NDVI. You can put any name, NDVI BD. I simply put the, and folder, you can put any folder name. So I simply put here the folder name is that, suppose 16 base. Okay, you can use any name. So I simply use here the 16 base, and then file name prefix not needed for this time. So I simply remove. Dimension not needed, I simply remove. Region is need. So region is your shapefile variable name. Shapefile is that ROI. I want to check the shapefile variable name. What is the shapefile variable name? You can see this is the ROI. Okay, so this is the capital ROI. I simply copy the variable ROI. Simply copy and just paste here. And what is the scale? Scale is your resolution of your satellite imagery. So in this time, this is the 500 meter resolution. I simply use here the 500, and CRS not needed. I simply remove it. Max pixel is need. So in this time, I simply, when you want to work with the big region, you can simply put the 1E13. Then it will be work. And I simply remove all of the things from here. And then click to the run. So now you can see in this time, our console tab is running. Our task tab also running. You can see it will be running sometime. You can see task tab will be running. In this time, you can see one file will be added here. This is called the NDVI. So I can simply click on the run, and now you can see all of the things. and then simply click to the run. So now it will be stored in my Google Drive, and from this Google Drive you can easily download this image, tip image, and then you can easily make the map layout and other things like this. So this process I also try to show you the next class, because in this time my PC is not the install the ArcMap software. Recent time I just reset my computer system, so that's why all of the previous software will be gone. So that's why in this time I also try to show you the next class. Okay, so you can easily make the map layout like this, no problem. Okay,
And how we know the point chart, like the CSV file or of this results?
okay, I also try to show you this, no problem. Okay, so in this class I also try to complete this part for how you can
Okay.
easily make this. Okay, no problem. In this time here you can see I just downloaded it, and you can easily make the any map. Also you can make the reprojected the scale value. Okay, so in this time I simply go to our today's class and then try to continue our today's class. So I simply open my slide. So hi and welcome to the second day's online training session on Google Earth Engine for remote sensing analysis for beginners class. So today is our second day and I am course coordinator, and today our course corner will be that first of all I will try to discuss about that how you can easily filtering and visualizing the satellite images in Google Earth Engine platform. So mainly I will try to show you that how you can easily filtering and visualizing the satellite images for the Landsat and Sentinel images, and then how you can easily export the satellite images in Google Earth Engine from the Google Earth Engine platform, how you can easily export the satellite imagery. And then I also try to discuss about that analysis of the NDVI value, making the time series chart. So suppose you want to make the NDVI time series chart, and now you want to make this NDVI time series chart. You want to just create the time series chart, okay, of this NDVI. So how you can easily make the time series chart of NDVI. I also try to discuss about this, and then I also try to discuss about that NDVI NDVI calculated from the MODIS and Landsat data. And then I also try to discuss about that how you can easily export the tip image from the Google Earth Engine platform. And finally, how you can easily export any shape file. It can be any shape file. How you can easily export the any shape file from the Google Earth Engine platform. I also try to discuss so that you can easily understand. So I simply open my. You can see, first of all, filtering and visualizing the satellite images in Google Earth Engine platform. So it is one of the most fundamental part of Google Earth Engine. You need to filtering and displaying the satellite images, which image you want to need. And this is the same process when you want to work with the Landsat or Sentinel imagery. We will try to follow the same process for filtering, and in this time when you want to filtering, you can just using the 4 factor or 3 factor. But first factor is that first of all you need to select your region of interest. You want to select your region of interest. Suppose you want to need the Landsat 8 satellite imagery for the region of Dhaka city. You need to filter your region. Okay, this is the first condition. You need to filter your region. This is the first condition. Okay, then you also need to filter your image properties. So image properties, it can be lot of things. Suppose you want to need only for those images which image will be not more than 1% cloud cover. So this is the one type of factor. Okay, so this is the another factor. And third factor is that you want to need these images only for the year of any specific year. Suppose you need the image for the year of 2017, or you need the image for the 2017 January 1st January. Okay, so we can easily filter the different time period of the images. So mainly when you want to filter the satellite imagery, we always try to maintain these 3 factor. First factor is that you need to select your region of interest. then you need to filter your image properties. Suppose in this time I also give the example is that suppose you need the image which image will be not more than 1% cloud cover. So this is the another factor. And another factor is that suppose you want to need only for the any specific time period image, you want to need only for the any time period image. Okay, suppose you want to need the image for the year of 2020, you need the image for the dry season, you need the image for the wet season. Okay, so you can easily filter all of the images using so this is another factor. So in this time I will try to show you that. So I simply open my code editor and try to this showing all of the process so that you can easily understand.
Okay.
So I simply open my new code editor. So first of all, we need to select our ROI or our region of interest. Okay, suppose in this time I want to need the images for the Dhaka city. Okay, so I simply import the shape file of Dhaka city because I need the Landsat 8 satellite imagery for the Dhaka city. So I simply open import my shape file of Dhaka city. So here you can I simply open my shape file. Wait a minute. So you can see this is my shape file. I want to need this region for the Landsat 8 images, any specific time period. I want to need these images. Okay, so I simply import this shape file. I simply click to the import. You can see this shape file will be imported and default variable name is the table. Here you can see default variable name is the table. If you want, you can simply change it. Suppose I can give the name is the RY. You can put any name, no problem. In this time, I want to work with which satellite image you want to need, or you want to work with these satellite images. You can simply import your satellite images. You can simply go to the browse data catalog. You can simply click to the browse data catalog, and in this browse data catalog you can find all of the Landsat imagery. I can simply click on the Landsat. So from this Landsat satellite imagery, here I can get all of the Landsat collection. Okay, so mainly it provided the USGS, NASA and Landsat program has been observing the Earth continuously since 1972. Okay, and it also provided the spectral and thermal data provided with the Landsat sensor are essential component of the many Earth monitoring and the research project. Okay, so we can easily get all of the Landsat collection from this Google Earth Engine data catalog. So that's why we don't need to download this any data. Okay, so here you can see they also give a notice. So please migrate your workflow from the Landsat collection 1 to collection 2. For collection 1 data have been served by collection 2. All data required after December 2. Okay, so you can also see they are also they are always put their update notice. Okay, so this data set will be updated daily. We can easily get all of the notice from here. Okay, so here you can see they are also in collection 2. In this time they are prepared to use the collection 2 because they are also need to the some updating issue for the collection 1. Okay, so in this time suppose I want to work with the data set. Suppose
I have one question.
yeah, ask
In
me.
Earth Explorer, mostly we use collection 1, but here which data we need to use, like collection 1 or collection 2?
So in this time there also need some specific work. So for this there also need some updating their data. So as soon as possible all of the data will be FAR'd in here, no problem. And we already know about that. Recent time they are also updating the Landsat 9 data set. So I think they also need some process for completing all of the things. So that's why they are also provide this notice for using this workflow from the collection 1 to collection 1 to collection 2. Okay, so they are collection 2. In this time they are stop this collection 2, and in this time they are also need some modification in this here. Okay, and as soon as possible this data catalog FVR for also collection 1 is FVR in here, no problem. Okay, so there are also some work in this time they are also, so that's why they are also in this time it will be not in here. Okay, so but all of the process will be same, no problem. So all of the filtering process or all of the exporting process, all of the process will be same. Suppose you can see actually there are the lot of sensor in the satellite. Suppose ETM sensor, OLI, TIRS sensor, OLI sensor. Okay, so we can get the different types of sensor, different types of imagery. Okay, we can easily get from here. Okay, so in this time, suppose I want to work with this data set, I simply click to here Landsat 9. So I can simply click to the Landsat 9. So here I can get all of the collection. You can see for the Landsat 9, surface reflectance data set, top of atmospheric data set, raw image. So which data you want to need? You can simply, suppose I want to work with the surface reflectance. So I simply click to the surface top of atmospheric. Suppose I want to work with this data set. So I simply click to here. Here I can get all of the information about this data set. Here you can see. You can see this data set availability. You can see between this time period, year of 2020, 21 from the 2020 and present time. Okay, and this is the very latest Landsat collection. It launched. Okay, so we can easily get between this time period. We can get this data set. Okay, you can see this is the data set provider is that USGS and Google. Also, you can see all of the things you can see. Okay, in this time, I want to work with this data set and try to download the data Landsat 9 from my Dhaka city region. Okay, so for this, I simply, first of all, I need to import the data set in my code editor. Okay, so I simply copy. I just copy the artisan snippet from here. I simply copy, and then I simply paste here. Okay, in this time, I simply put a variable name. Suppose I put the variable name is that. Okay, I can simply put the variable is that. Suppose. Okay, and if you have any question anytime, you can ask me. No problem. You can see here in this time, I want to just take a variable name. Suppose I put the variable name is the L9. Okay, you can use any variable name. In this time, you can see I just simply put the variable name L9, and this L9 is a variable name. In this time, this variable is stored. This variable is stored all of the collection of Landsat 9. I want to check it. How many images is available between this time period, year of 2020 to present time? How many images is available? I want to check it. So I simply use here the print function, and then use here the L9, and use here the size function. Okay, then click to the run. So now you can see it will provide me all of the collection. How many Landsat 9 images is available? You can see it only for the 95,412 images. Okay, they're not mass. Okay, but because this Landsat 9 is recently launched, okay, we can get the data, but we can see from the year of 2020, 21.
This is for the
Okay,
whole world. This 9,000 images.
yeah, for the whole world. For the whole world, we can get these images.
Okay.
95,412 images for the whole world. We can between this time period. You can see. Okay, in this time, I don't need for the whole world image. I want to need only for my region of Dhaka city. I need the image only for the Dhaka city. So when you want to filter this large collection image respect to your region of interest of Dhaka city, then you need to use a function. This function called the filter bounds. So I simply take a variable and give the variable name is the, suppose I can simply put the variable name is the filter region. You can use any name. In this time, I don't need for the whole world image. I want to need for the image for my own region. Okay, so in this time I simply call my collection L9. Okay, because this L9 is stored all of the Landsat 9 image collection for the whole world. I simply use here the filter bounds. Okay, then you can see what is the argument. You can see this argument is the geometry. And what is the geometry? Your geometry is that your shapefile variable name. So your shapefile variable name is that ROI. Okay, in this time I want to check how many images is available only for my region of Dhaka city. I simply use here the print function, print, and then simply call my variable name is the filter region, and then I simply use here the size function. and then click to the run. So now it will be showing me how many images available for the Dhaka city. We can get only for the 25 images. Okay, you can say I can get the 25 images. And what is the time duration? What is the time duration? You can see between this time period, year of 2020, October 31 from 2020, 29 June. Okay, I can get this for the Dhaka region. I can get here only for the 25 images. Okay, in this time, this 25 images has a lot of characteristics of images. Suppose in this time I want to need only for those images which image will be not more than 1% cloud cover. I want to need only for those images which image will be not more than 1% cloud cover. So this is the another properties for your image filter image metadata. So in this time I simply take a variable and give the variable name is the suppose filter metadata. Okay, and what is the filter metadata? Filter metadata is that image properties. You can see every image has a properties. You can see cloud cover land, cloud cover category, cloud collection number. Lot of properties will be available here. In this time I want to need only for those images which image will be not more than 1% cloud cover. So this is my cloud cover. I simply copy the cloud cover. Okay, and then I simply call my filter region. So I simply call the filter region because this filter region stored the 25 images. From this 25 images, I want to need only for this images which image will not be more than 1% cloud cover. Okay, I want to need from the 25 images. Okay, so I simply copy the 25 I simply copy the variable name and paste here, and then use here the filter metadata. Okay, then you can see what is the argument of this filter metadata. This argument is the name, then operator, then value. Okay, so what is the name? Name is the image properties cloud cover. Okay, so name is the image properties. You can see what is the image properties is the cloud cover. I simply copy the cloud cover and then paste here, and then operator. So what is the operator? You can see I want to need the less than. I simply use here the less than. And what is the value? I want to need the less than 1% cloud cover. I simply use here the 1. And now I want to check how many image is available for my Dhaka district, Dhaka city region. Which image is less than 1% cloud cover? How many image is available? I want to check it. So I simply use here the print function, print, then simply copy the filter metadata and paste here, and use here the size function. So now it will be showing me how many image is available. Which image is the less than 1% cloud cover? You can see very less image, only for the 4 image, only for the 4 scene or image I can get this image is the less than 1% cloud cover. Okay, for the between this time period, here you can see between this time period, okay, between this time period I get the images. Okay, so in this time, suppose you can see if you want, you can see between this time period I can get the 4 images, very less image. Okay, so in this time, suppose I want to need for the all of the images, suppose which time period is available in here, I want to work all of the images with this here. But if you want, you can also filter your specific time region. Suppose you want to need the only for the November, only for the December of 2021. Okay, or 2021 January to 6. Okay, it will be, you can easily filter. Suppose I want to filter the specific time period. Suppose okay, so I want to check. I also try to show you that. Okay, so I simply take a variable and give the variable name is the filter date. Okay, in this time you can see this 4 image is the less than 1% cloud cover, less than 1% cloud cover between this time period. Okay, in this time I want to change the time period, so I simply call the filter metadata. From these 4 images I want to need only for the image which image is stored between this time period. I can simply put here my time period, start date and end date. So what is my start date? I simply put here the year of 2020, suppose 1st January, from I simply put year of 2020 06, and what is the date? We can see what is the last date is that 29. I simply put here the 29. Okay, and then I want to check it how many images is available between this time period. I simply use here the print and use here the filter date and paste here and use here the size function and then click to the run. So now you can see we can get the 3 images. Okay, these 3 images is available between this time period, and this 3 image is the less than 1% cloud cover, and this 3 image is situated in my region of interest. Okay, so in this time I want to work with the 3 images. So in this time, if you want to need the specific time period, suppose you want to need the specific time period when this image is captured by satellite 9, you want to check it. I simply use here the print function and then I simply copy the filter date, just copy and then click to the run. So now you can see in this time it will be showing me all of the information about the image, when this image is captured, all of the details we can see here. You can see from the feature here you can get the 3 images. The first image is the captured year of 2020, 7 January. Second image also captured the same date, 7 January, and third image is the capture with the 8 February of 2020. Okay, so here you can see this is the single image. Okay, if you want you can also work with the single image. Suppose you want to work with only for the image which image is the captured year of 2020, 1st January, you can also work with this. When you want to work with the single image, you can simply copy this ID. You can simply copy this ID. Suppose you want to need for only for this image. Okay, only for this date images, specific date images. I simply take a variable and give the variable name is the suppose image, and then use here the ee.image, and then I simply paste this ID. This is my ID. I simply paste, and this image is the captured year of 2020, 7th January. Okay, I want to check it. I simply use here the map.add layer, and then I simply copy the image and then click to the run. You can see a new layer will be added here, but I did not see these images in here. In this time I want to need the focusing the shapefile. I simply use here the center focusing, map center object. This is my ROI and zoom level is a 10, and then click the run. So now you can see what happened. It will be showing the scene. You can see it will be showing the as a tiles of satellite imagery of line set 9. Okay, so you can check it. You can see it will be cover or not for my region. I want to check it. So that's why I simply use here the clip function. So when I want to use the clip function, it will be clipping with my shape file. Clip with ROI, then click to the run. So now you can see what happened. I can get only for the satellite images for Dhaka. You can see this image is not cover my full region. You can see this this type of image, this type, this you can see there is the no image in this part. In this time I want to check it another image, it will be covered my area or not. I want to check it. So I simply take the second image and then I simply copy this ID again from here. Just copy this ID and then I simply paste here. Now we can check it will be covered or not. We can check it. Okay, so I can see this image is the covered my full area. Okay, so this is my full area of Dhaka city. It will be covered the image. You can see this is second image is the covered this region. You can see in this time I want to add here the different types of band. You can see this I want to add here the red, green and blue band. Also increase the states for better visualization. 98%, click to the apply. So now you can see what happened. So now you can say I can get the Landsat 9 satellite imagery in here. Okay, so
like, 11 bands in Landsat. How many bands in
Here in this image you can see, in this image it also showing the total 17 bands. All of the image has the total 17 bands. All of the image. Sorry. So here you can see, first image, this is the 17 bands. Second image, this is 17 bands. Third image is the second 17 bands. All of the image has the total 17 bands. So in this time here you can see, I want to work with a single image. But if you want to need the any median pixel value image, if you want to need the average pixel value image, if you want to need the maximum pixel value image, then we need to also follow the another method. Suppose in this time I want to show you that how you can easily create the median image. It will be only for the single image. In this time I want to create the median image from the all of the images, all of the images. I want to create the median image. Okay. So for this it will be easy. So I simply use here. You can see I simply commenting this. Yeah.
Nowadays, for our research purpose, we need like to use the median image mostly.
Yeah, so mainly we can use the median image and it will be better visualization for the satellite imagery. When you want to take the median image or average image, all of the, actually this median is created from these three images. Okay, these three images is created this median value. Okay,
and they are composed of like the summer and winter both.
Yeah, any question you can ask me.
Okay. Like the median image is composed of both summer and winter data, both.
Yeah. So median image is created the all of the images median value. Okay, all of the images created the median value and get the only for the one image. Suppose you can see there are the total three images. Okay, and these three images, when I use the median function, and these three images created the median value. Three images pixel value. Okay, three images pixel value created the median value. And when I use the mean, it will be created the average value. When I use at the max, it will be created the maximum pixel value. When I created the mean, it will be created the minimum pixel value. Okay, so it's totally depend on the pixel value. Suppose when you want to get the better pixel value, then you can see the image is the more better. Satellite image you can get the more better. Okay. Okay. So in this time, I simply take a variable. And then I simply put the variable name is that I can simply put the variable name is that final image. So final image. Okay, and then I simply call my filter date function because it will be stored total three images. I simply call him. From the three images I want to create the median value. Okay, then I simply use here the clip function. It will be clip with my ROI. Okay, and now I want to show the result. I simply use here the map.add layer, and then I simply call the final image, and then I simply click the run. So now you can see this image is showing the median pixel value from all of those three images. Okay, so I created this composite like this using the median value. In this time here you can see I want to add the visualization, so I simply use here the V4, V3, V2, and also increase the 98% for better looking, then click to the apply. So now you can see this image is the looking the more better. You can see because this composite is created from the three images median pixel value.
Yes.
Suppose in this time I want to use here the max. You can see what happened then. I simply use here the max. In this time it will be get all of the three images, take the only for the maximum pixel value. I want to simply just use here the ben 4, 3, 2 and 8%. In this time you can see, in this time we can get the maximum pixel value from the 3 images and created this composite only for the one composite. Okay, when I want to use here the mean, you can see now it will be showing the mean pixel value of all of the 3 images. Okay, so you can easily, which data you want to need, you can easily down get the mean, maximum, minimum, medium, average, all of the pixel value. You can easily create it the composite like this, and you can easily export this image. Okay, so in this time here you can see I can get the image for the Dhaka city. In this time you can easily export this image as a TIFF format, and this is the same process. Which process I want to show you in here, you can follow the same process and you can easily download this images in here. So I simply copy and then I simply paste this code in here. Okay, then you can simply, you can see what is the object you want to show. What object you want to show, you can just simply put the variable name. I want to show the object is the final image, so I simply copy and paste here. You can use the description, anything, so I can simply put the description, suppose Dhaka Landsat. Okay, and all of the things, and this the resolution is a 30 meter for Landsat. Okay, and then click to the run, so then it will be okay exporting. Okay, so this is the same way you can easily export this all of the Landsat collection, and here you can see there is a lot of Landsat collection will be available in here, and it's also this data set also updating. You can see Landsat 9, Landsat 7, all of the data set you can easily access it from here. Landsat 8 surface strip, and all of the images has the same process.
Okay.
Okay, so you can see. Okay, so in this time I simply go to my next slide and try to discuss about the next topic. In this time I will try to discuss about that how you can easily make the NDVI time series chart for any specific region, and from the chart how you can easily download the NDVI time series data. Okay, like this you can see this is the chart of NDVI time series chart of Dhaka city, and from the chart we can easily download the data. Okay, and in this time this data can be different type of data. Sometime you need to the annual NDVI time series data. Sometime you need to the 7-day interval time series data. Sometime you need to the monthly NDVI data. Sometime you need to the yearly NDVI data. Lot of data set will be available in Google Earth Engine platform. Okay, so which data set you want to need, you can simply import this data set and you can easily work with this data set. Okay, so lot of data set will be available. Yeah, ask me any question.
No question.
Okay, so in this time we will try to explore all of the data set for the 7th interval, then monthly, then yearly, all of the interval, and then created the time series chart and download the Excel file, all of the data. Okay, so I simply,
that was my question, that how to like create
okay,
Excel chart, like Excel. Okay.
so in this time I simply open my